All right, so let's work through this one together, and we'll take it piece by piece. So let me read the full thing first, and then we'll go from there. So it says a perfect cube-shaped ice cube melts so that the length of its sides are decreasing at a rate of 3 millimeters per second. Assume that the block retains its cube shape as it melts. At what rate is the volume of the cube changing when the sides are 2 millimeters each? All right, so first of all, let's start with the shape here. So it says a perfect cube shaped ice cube. Okay, so if ice cube, if we didn't think of it as a cube already, they tell us explicitly it's a perfect cube. All right, and we're talking about the rate of volume and sides, right? So those are the things that are relating to one another, right? The volume and the sides. And so think about what formula could we use for a perfect cube in terms of volume and sides, okay? And this is one that's actually not on your formula page explicitly. There's one that's of a rectangular prism, which a cube is, but it's a more specific version. So think this is the area of the base, and think of the area of a square. If the base is a square, that would be side times side, right? And then the height is also going to be a side, okay? So so what would be the final version of that formula? Okay, and I'll ask you a question here on the play posit. So what's the volume of a square in terms of its sides? All right, good. If you put side cubed, then that's great. So, and I just have a little diagram here, and you don't have to show all this work. Just start with the formula there. But and you don't have to draw this diagram either. And you might know this already intuitively, but side times side times side, right? That's how we do the area of a cube or any really rectangular prism. But in this case, all the sides are the same, and so side times side times side is side cube. All right. Anyway, so now let's find our related rates formula, right? So what we're going to do, or let me ask you, how do we get from our relationship to our related rates formula? Good. And if you said differentiate with respect to time, that's perfect. So it's funny. So if we ddt this thing, so now go ahead and do that and select the result of what you get after you take the derivative with respect to time. All right, perfect. If you got v prime equals 3s squared times s prime, that's perfect, right? Just take the derivative of each term, and don't forget to tag on the primes, because everything, unless you have a t in there, everything's going to tag on a prime, right? Because we're deriving with respect to time. All right. So from here, now let's start plugging in values, okay? So let's real quickly think about our rate that they give us, right? We have this word melts here, okay? And there's another clue in this statement that makes it pretty clear, but let me just ask this question. Does that imply that the value or the rate is increasing or decreasing? Good. If you said decreasing, that's right. And it also says decreasing right here. So it says decreasing at a rate of 3 millimeters per second. But notice how it doesn't put the negative in there. So you do have to remember that we're talking about the length of the side, right? So in other words, s prime, and it decreases at a rate of 3. And so we're going to put s prime is negative 3. So that's what we're going to plug in right here, negative 3. Okay. All right. And then it says finally here in the question, it says at what rate is the volume of the ice cube changing? So let me do this. So volume of the ice cube changing. So they're asking for v prime, right? Actually, let me keep that in. They're asking for v prime. At what rate is the volume changing? And then it says when the sides are 2 millimeters each, right? So that means S equals 2. And so we're going to put 2 in here for S. All right, so S prime is -3, and S itself is 2. So now we have everything we need to input into our formula. So go ahead and plug all that in and get your answer, okay? All right, good job. -36 is what you should get. And now what would our units be? Good. So since we're dealing with volume, we're going to have cubic units, right? Remember, one-dimensional objects have one-dimensional units. Two-dimensional objects like squares, circles, etc. have two-dimensional units, squared units, and volume is a three-dimensional measurement, like for solids like spheres and prisms and cones and things like that, and those have three-dimensional or cubic units. Okay, so since we're dealing with millimeters, our volume is going to be in millimeters cubed. All right, so that's our final answer, and that's how to put together a related rates question where the sides are decreasing.